In this final video of looking at transformations of trigonometric functions, we're going to be looking at example 3, which is on page 6 of your C-13 handout. So what we're going to do is take an equation that has everything thrown in, all right, vertical, horizontal, stretches, translations, and so forth, and see how we handle that. But I want to stress, first of all, that once we get to this type of equation where we have all the transformations going on, the general form, the way we write it, is we write it as y equals a sine of b times the quantity x minus c plus d. And where those letters come from, if we go back on the pages, like if we just go back one page, you can see that I made the interior changes b times the quantity x minus c. So you see that repeated here. And then if I go back to this page, you can see that I made the exterior changes, the outside changes, the vertical ones, A and D. So you can see that reflected here where I have the A out in front and then the D at the end. So as I'm going through and talking about some of these values, that's where those letters are coming from. So the period, if you remember on the last page, for sine function, we said is 2 pi divided by the absolute value of b. So in this case, it'll be 2 pi divided by the absolute value of b. And b in this problem is, remember, b is the coefficient that's here, and that's going to be 4. So it's going to be 2 pi divided by 4, which is pi over 2. And after we graph it, we'll come back and double check that. The amplitude, remember from a previous page, amplitude is the absolute value of a, and a is the leading coefficient right here. And so that's the 3. So the amplitude of this one is 3. And then the vertical shift, so vertical shift is going to correspond to the d right here, which is minus 1. So we're going to say that this is down 1. And then the phase shift, remember phase shift is the same as horizontal shift. Actually, now I'm wondering if I ever said that. Phase shift is the same as horizontal shift. So the horizontal shift comes from this, and so we can see that that's the plus pi over 4, but remember that means that we are going left pi over 4. And then the equation of the principal axis, so the principal axis, remember on any of these, starts out at y equals 0, and it's not affected by anything horizontal. It's only affected by the up and the down, and it turns out that it's the same as d. So the principal axis is always y equals d, but in this case that is y equals negative 1. That's our value. So like I said, we'll come back and we'll double check everything once we've graphed it. All right, so now how do we make these changes? Well, remember that whether you're doing vertical or horizontal, you always do the stretching and the flipping first, and so that's the multiplier. And so I'm going to take care of these kind of all at once. And so if I'm doing the vertical change, remember that changes the y values, and so I'm going to be multiplying all my y values by 3. So I'm just going to write that in here as a reminder. And then when I do the horizontal changes, the horizontal stretching, my scale factor is the 1/4. So the scale factor is 1/4. And so that tells me that I'm going to multiply the x values by 1/4. So in my first line here, that means that I'm going to end up with 0, 0. And then I'm just going to multiply down the line first with the 1/4. So that's going to make this next one pi over 8. Again, I'll let you do the arithmetic. And then I'm going to have pi over 4. And then I'll have 3 pi over 8. And then I'll have 2 pi over 4, which is the same as pi over 2. All right, then I'm going to go through and multiply all my y values by 3. So this next one will be 3. The next one will be 0. Next one will be negative 3. And then the last one will be 0 again. I'm going to get rid of some of this because I need some room to do the next line. All right, so on the next line, now I'm going to do the shifting. So when I do the shifting, first of all, for the verticals, that comes from the minus 1, so I'm going to be subtracting 1 from all my y values. And then for the horizontal, remember that changes the x values, and that's going to be subtracting pi over 4 from all of the x values because of the fact that that's plus pi over 4. So again, I'm just going to go down the line and do that. So my first one is going to be 0 minus pi over 4, so negative pi over 4, negative 1. The next one is pi over 8 minus pi over 4, and I'll let you do the arithmetic for that. That's going to be negative pi over 8. The next one, pi over 4 minus pi over 8, so that's going to give me, or I'm sorry, minus pi over 4, so that's going to give me 0. The next one is 3 pi over 8 minus pi over 4, so that's going to be positive pi over 8. And then the last one, pi over 2 minus pi over 4 is pi over 4. And then with the y values, I'm subtracting 1, so I already have the negative 1. 3 minus 1 is 2. 0 minus 1 is negative 1. Negative 3 minus 1 is negative 4. 0 minus 1 is negative 1. So that gives us all of our new ordered pairs for our transformation. So now we'll go down here and graph that. And I notice that these are symmetric. So the first x value is negative pi over 4. The last one is pi over 4. So when I graph this, I'm going to kind of center it. And just evenly space, because these are evenly spaced numbers. So I have negative pi over 4, negative pi over 8, 0, I don't have to write that, pi over 8, and pi over 4. My y values then changed to, you'll notice that the low is negative 4 and the high is 2. So I'll have 2 here, just kind of estimate. And then the negative 4, so this is a distance of 2. So if I go down 4, so just kind of estimate here. So I'm going to have this be negative 4 and this be positive 2. And then my middle value is going to be the negative 1. So negative 1. And you do want to check, you know, this distance right here and this distance here should be the same. And notice that from 2 down to negative 1, that's a total distance of 3. And then this is a total distance of 3 also. So what that means is, as far as my box, if I want to kind of box it in, is that this will be sort of the left edge, this will be the right edge, this will be the top, this will be the bottom, and then this will be my principal axis. So since this is a sine graph, remember that the sine graph hits the principal axis at the beginning, the middle, and the end. At the quarter point, it goes up, and we notice that there's no flip here. It's a positive, so that means it's going to go up. And then at the 3/4 point, it's going to go down. And so then just sketching out what that one period of a sine graph looks like, there's our graph. Now, like I said, what we want to do is kind of check some of these values that are up here. So if we check the period with ours, the period, ours goes from negative pi over 4 to pi over 4. So if I subtract that, pi over 4 minus negative pi over 4, that's the same as plus. That gives us 2 pi over 4, which is pi over 2. All right, so we can confirm that we got the right period. The amplitude we said was 3, and if you look at the amplitude as being this distance from the principal axis up here, we've already confirmed that that is a distance of 3. And then going from the principal axis down is also a distance of 3. So that one also works. And we can see that our new principal axis is y equals negative 1. Right here is that y equals negative 1. So it's always a good idea to kind of go back and confirm some of those things and make sure that that works.